We've had a 3.5 earthquake just within this hour. You notice that the red is the past hour, blue is the past day, and yellow is within the week. And this is a 3.5 that we had a depth of very close to the surface, 2.6 kilometers. And this one here, 3.4 magnitude on the 26th of June, right in the same area, and about a mile apart. And this one here today, 3.5. Pulling out, that's an area of rivers. We know that wherever we have rivers, we have fault lines. All rivers are fault lines. There's South Carolina, and it shook Georgia and up to Raleigh. Let's take a look at the shake maps. Here we are, North Carolina, Georgia, Atlanta. Of course, unfortunately, USGS stops that block. The frequency, shaking frequencies right there. But this is Georgia, and this is, of course, North Carolina. And going back to this. And this is the second quake in the third day. So this is a quake swarm. It's in the same area. It's only a mile apart from the first one that we saw. And this, of course, is felt 10 times more than it's felt on the West Coast because all this area here is soft. And it's felt more than it is on the West Coast. Okay, it's within this past hour, so a lot more people will be reporting it. Over 3,000 have reported so far. And this is the area. Tectonics. Since at least 1776, people living inland in North and South Carolina and adjacent parts of Georgia and Tennessee have felt small earthquakes and suffered damage from infrequent larger ones. The largest earthquakes in the area, 5.1, occurred in 1916. Moderately damaging earthquakes strike the inland Carolinas every few decades, and smaller earthquakes felt about once every year or two. Earthquakes in the central and eastern U.S., although less frequent than the West, are typically felt over a much broader region. East of the Rockies, an earthquake can be felt over an area as much as 10 times larger than a smaller, similar magnitude earthquake in the West Coast. A magnitude 4 earthquake in eastern United States typically can be felt at many places as far as 60 miles from where it occurred, and it infrequently causes damage near its surface. A magnitude 5.5 eastern US can be felt 300 miles. So how many miles was this felt? Let's see. Okay, they stopped it there. But this is what? This is the scale right there, 50. So let's go. It's 50, 100, 150, maybe 200. Okay, because this is soft. This is on the coast, so you can see that the area is. Do we have any liquefaction here? No, they don't have liquefaction here. This is the area right here. Okay. Fault lines. Earthquakes everywhere occur in faults within bedrock, usually miles deep. Most bedrock beneath the inland Carolinas was assembled as continents collided from the supercontinent about 500 to 300 million years ago, raising the Appalachian Mountains. Most of the rest of the bedrock formed when the supercontinent rifted apart about 200 million years ago to form what are now the northeastern United States, the Atlantic Ocean, and Europe. At well-studied plate boundaries like San Andreas Fault System in California, often scientists can determine the name of a specific fault that's responsible for an earthquake. In contrast, east of the Rocky Mountains, this is rarely the case. The inland Carolinas region is far from the nearest plate boundaries, which are the center of the Atlantic Ocean and in the Caribbean Sea. The region is laced with known faults, but numerous smaller or deeper buried faults remain undetected. Even the known faults are poorly located at earthquake depths. Accordingly, few, if any, earthquakes in the inland Carolinas can be linked to named faults. It's difficult to determine if a known fault is still active and could slip and cause an earthquake. As in most other areas of the Rockies, the best guide to earthquake hazards, the seismic zone, is the earthquakes themselves. Now, we said every river is a fault line. That's the first thing you learn in geology. I took one geology course in college, and it was fantastic. We had a lot of field trips too. And as we said, let's take a look. I want you to see, okay, this area here. This is the New Madrid, this is New Madrid seismic zone. Okay, this is actually, should be called the Rift Valley because it's cutting off there. St. Lawrence River, Lake Ontario, Lake Erie, and Mississippi River, of course, all this cutting off. And this area here, the Great Lakes, is a mantle plume underneath. There's magma underneath that's been there almost 1 billion years. And it's like a horse-shaped thing. The eastern area goes under the New Madrid seismic zone, and the western area goes through here. Minnesota, Nebraska, Kansas, Oklahoma, Texas, and then goes to the west. Okay? And Kansas has a lot of kimberlite diamond spewing volcanoes. There is that magma from that mantle plume there. Most people don't know it, but we learned it because we did a lot of videos and from articles on this. So also here, let's remember that these are 30 seamounts. Okay, these are seamounts on the east coast pointing towards Maine. Maine has 5 volcanoes, 4 of them in a 100-mile radius. And if we go here, let's go to our thing. Here, our frequency map, shake map. These are the seamounts. You can see them much better here, right, underneath. And we do have methane volcanoes here on the east coast, just as we do on the west coast. Okay. This is the Gulf here. Let's go to the west. Okay. West coast. Seamounts here as well. Okay. Okay, you can't really see them on this map, but we do have methane volcanoes here on the east, just as you have in the west as well. So all of you there, please be very careful. Look at all this. This is just within this past hour, this earthquake. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.